Okay, in this tutorial, we are going to solve question 7 for 2020 chemistry exam final. So the question reads, the diagram below was used to measure the rate of reaction. The initial mass of the beaker and its content was 50 gram. So the picture here is illustrating what the statement is saying, where the beaker and everything inside it is equal to a mass of 50 grams. The graph below shows how the reaction between limestone and hydrochloric acid proceeded with time. So this is the rate of a chemical reaction, how fast the reaction is taking place. That's what they are trying to illustrate on the graph between limestone and the hydrochloric acid. Gentlemen and ladies, limestone and hydrochloric acid. A limestone is a chemical called calcium carbonate. So it is also good that as we proceed with our solvings, we also just illustrate this chemical reaction we are dealing with. The chemical reaction we are analyzing its rate. So the reaction here is that calcium carbonate, which is the limestone in that beaker, is reacting with hydrochloric acid, and the product will be a salt, which is calcium chloride, plus water plus carbon dioxide. So this is our reaction. So we can also check if it is balanced, just for the sake of assurance in our okay, so this is the reaction we are looking at between calcium carbonate and hydrochloric acid, giving us calcium chloride and water plus carbon dioxide. So our graph is showing the loss in masses with time, how the mass of our content in the beaker is being used up or is forming product, because on our product here we have a gas, so we know our gas, as the gas is being formed, the mass of course of our reactant will keep on reducing, so the mass initially was at 50, and we can see after 2 minutes it's dropping to somewhere 40, after another 2 minutes it's dropping to somewhere 33, after 6 minutes it's dropping to 27, after another 2 minutes, at 8 minutes now we can see here it's dropping to 20, 21, 22, 23, 24, 25, 26, 27. Yeah, even at 10 minutes is still at 27. So this indicates that the reaction here is done. It has leveled up. There is no more change with time. Nothing is happening. The reaction is over. Okay? So proceed with the first question, which reads, what mass of carbon dioxide was lost when the reaction went to completion? So what mass of carbon dioxide was given off when the reaction went to completion? So we go back to our graph. You check where the reaction is leveling off, where it is constant. So you can see that on the 8th and the 10th minute here, between the interval 8 and 10, the reaction is constant, meaning here the reaction was over on the 8th minute. So what was the mass lost at that time? So we can see that um, our mass, you go like this, then you keep going like this, like that. So this is 21, 22, 23, 24, 25, 26, 27. Okay, at 27 there, that's where our mass is. You can even start from here, because since this is 20, 21, 22, 23, 24, 25, 26, 27. So at 27, that's where, that was the mass in the beaker as the reaction completed. So at the end of the reaction in our beaker we had the 27. Okay, so what do we do now to find out the mass of of the carbon dioxide which was lost or which was given off, we'll say, since at the end initially we started with 50 gram, so minus the mass which was in our beaker there at 8th minute, we've said it's 27. So what's the difference between the two? It is 3 gram. So this was the mass of carbon dioxide which was lost at the end of the reaction. 3 gram of carbon dioxide was lost at the end of the reaction. Okay, so I mean 23 grams. 50 minus 27 is 23 grams. So 23 grams of carbon dioxide were lost at the end of the reaction. We move on to the second question, which reads: calculate the mass of calcium carbonate used in the first 1 minute. Calculate the mass of calcium carbonate which was used in the first 1 minute. So on our graph, the graph is just indicating the graph is just showing the number of the amount of carbon dioxide which was being lost with time. So now for us to find for the mass of calcium carbonate which was used up, let us just analyze first the carbon dioxide which was given off. So at 1 minute, which is somewhere here, at 1 minute, which is somewhere here, half of 2, you keep going up on your graph up to somewhere there. Yeah, so this is 1 2 3 4 5, so half is here. Then you check where it is meeting the graph, how much mass do you have. So it's somewhere here. So you have 40, 41, 42, 43, 44, 45, 46. Okay, so the fifth one, 1 2 3 4 5, is touching the graph at 46 here, somewhere here. That's why it's touching the graph. So the mass here is 46. The mass which remained there for carbon for our content in the beaker at 1 minute was 46. So what we'll do now is this. Okay, what we'll do now is this. What we'll do is this. Since initially we started with 50 gram, and at 1 minute we have found our mass to be 46 gram, so the difference is 4 gram. So this was the mass of carbon dioxide which was lost. Okay, but the question wants us to come up with the mass of calcium carbonate which was used. So we go now to our reaction here. You compare the calcium carbonate and the carbon dioxide. They are in which ratio? You can see here they are in the ratio of 1 to 1, and these are molar ratios. Okay, these are the molar ratios. So their ratios are, they are in the ratio of 1 to 1. Okay, and in 1 minute we've been told that the mass of carbon dioxide here is 1 gram. So we can first of all calculate the number of moles for carbon dioxide, and we know that number of moles is equal to mass over molecular mass. So the mass which which was given off for carbon dioxide in 1 minute was 4 over, what is the molecular mass for carbon dioxide? Molecular mass of carbon dioxide is the total of individual masses here. So oxygen, we have one oxygen is 16 by 2, we have 32, plus carbon is 12. So what is 32 plus 12? This is 44. So it's 4 divided by 44, which will give us 4 divided by 44, 0.09. So 0.09 moles these are the moles of carbon dioxide at 1 minute. Then now let us find the number of moles for calcium carbonate based on their ratios. We have from our equation the ratio of carbon dioxide to calcium carbonate to be in the 1 to 1. So this simply means that we also at 1 minute we also had 0.09 moles of calcium carbonate because their ratio is just 1 to 1. So if one piece of calcium carbonate was used up, there is also one piece of calcium carbon dioxide was being given off. So if 0.09 pieces of carbon dioxide were given off, it means there is also 0.09 moles of calcium carbonate being used up. So we use the number of moles now for calcium carbonate to calculate its mass at that minute. So yeah. So in that regard, would say we use the relationship which say number of moles is equal to mass over molecular mass. So the number of moles from calcium carbonate now is the one we are dealing with. We've said it's 0.09. Then the mass is the one we are looking for over what is the molecular mass of calcium carbonate. Calcium carbonate, calcium carbonate. Okay, so here we have oxygen, it's a 16 by 3, then carbon we have 12, then calcium we have 40. So this will give us 40 plus 12 plus 16 by 3, that's 48. So 48 plus 12 plus 40. So the molecular mass of calcium carbonate is 100. So in short, our molecular mass here is 100. So therefore, the mass will be, what is 100 multiplied by 0.09? So 9 gram. So this was the mass of calcium carbonate used up. Okay. Then question C says, on the same graph, sketch how the cave would appear if powdered limestone was used. Sketch how the cave will appear if powdered limestone would be used instead of solid one, because it is a chalk in short. Limestone is also called chalk. So state how the graph will appear if a powdered one is used instead of its pure form, which is a chalk. Okay. 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 So how now will be the graph going to appear? So the graph, if we use a powdered one, it means most of it will be used up. It won't be saturated like the way it is here, because the number of particles influences the rate of the reaction. Okay. So the reaction will be a complete one. The reaction will be a complete one. So our graph, if we had a powdered limestone, it would have been a faster one, because the rate of a chemical reaction, the speed of a chemical reaction is influenced by the particle size. So when the sizes are so small, it means the reaction also occur faster. So you expect a reaction to complete very fast. You expect a reaction to complete fast. Okay. So our sketch for that case would be, okay, it will be complete since it's powder. It will be complete. It will be something like this instead of the way it was like that. It completed much faster because of the solid particles. The solid particles were not completely used up. So now that it's they're in powdered form, we expect something like this, at least it to end kuma last like that. So that would be the sketch which would be expected if we used powdered calcium carbonate instead of the raw calcium carbonate, which is a chalk. A chalk is a solid.